Before we dive into capacity planning, let's recap how we measure system load. We use concepts like arrival rate, service rate, utilization, and Little's law to understand how busy our system is and how efficiently it processes requests. These metrics help us see whether our current setup is keeping up with demand or if we're starting to fall behind. By monitoring these numbers, engineers can spot bottlenecks and decide when it's time to scale up. This foundation is essential for making smart decisions about future growth, which brings us to the next big question. Can our system handle more traffic? As your application grows, you need to ask, how do we know if our system can handle future traffic? This is where capacity planning comes in. It's not just about today's numbers, but about preparing for tomorrow's challenges. Whether you're expecting a steady increase in users or a sudden spike from a major event, capacity planning helps you estimate what resources you'll need to keep your application running smoothly. By thinking ahead, you can avoid slowdowns, outages, and unhappy users. Let's see how this works in practice with a simple example. Imagine your application currently receives 100 requests per second, and one server can comfortably process 100 requests per second. Everything is running smoothly. But what happens when your company announces a major sale and engineers predict traffic will jump to 1,000 requests per second? Suddenly, your single server isn't enough. You'll need to scale up to meet the new demand. This scenario is common in real-world applications, especially during special events or promotions. Let's calculate how many servers you'll need to handle this spike. If one server can process 100 requests per second, and you expect 1,000 requests per second, the math is straightforward. Divide the expected traffic by the server's capacity. 1,000 divided by 100 equals 10 servers. So you'll need about 10 servers to handle the load. But this calculation is just the starting point. In practice, engineers often deploy more than the minimum number of servers to account for unexpected spikes, slowdowns, or failures. This safety margin ensures your system stays reliable even when things don't go as planned. Deploying exactly 10 servers might seem logical, but engineers know real-world traffic can be unpredictable. Sudden spikes, slow database queries, or even server failures can reduce your system's capacity. To stay safe, engineers often deploy 12 or 15 servers instead of just 10. This extra capacity acts as a buffer, keeping your application fast and reliable even when unexpected issues arise. It's a practical example of capacity planning in action, showing how careful estimation and a safety margin can make all the difference. Capacity planning isn't just about counting servers. Engineers also estimate CPU and memory requirements, database capacity, connection pools, network bandwidth, storage needs, cache size, third-party API limits, and cloud infrastructure costs. Each of these factors can become a bottleneck if not planned properly. By considering all these elements, engineers ensure the application remains fast, reliable, and cost-effective as traffic grows. This holistic approach is key to successful capacity planning in modern systems. The ultimate goal of capacity planning is to keep your application fast, reliable, and cost-effective, no matter how much traffic it receives. By estimating and preparing for future needs, engineers can avoid slowdowns and outages. This proactive approach means your users enjoy a seamless experience, even during busy periods. It also helps your company save money by avoiding over-provisioning and making smart use of resources. Capacity planning is a balancing act between performance, reliability, and cost. Cloud platforms have revolutionized capacity planning. Instead of manually adding or removing servers, applications can now automatically scale based on demand. This flexibility means you only use the resources you need when you need them. Auto-scaling helps keep your application responsive and cost-effective, even as traffic fluctuates. Engineers can set rules to add more servers during busy times and remove them when things quiet down. This dynamic approach is a game changer for modern applications. Capacity planning is an ongoing process. As your application grows and changes, you'll need to revisit your estimates and adjust your resources. By staying proactive and flexible, you can ensure your system is always ready for whatever comes next. In the next video, we'll explore auto-scaling in more detail and see how it helps applications adapt to changing traffic in real time. With the right planning, your application can stay fast, reliable, and efficient, no matter how big it gets.